Manufacturing Technology 2, present by Dr. Y.Carlin Calph, Associate Professor, HOD, Department of Mechanical Engineering, PSN College of Engineering and Technology. So first we go for the rolling process. Important applications: steel plants, rods, stock production, sheets, tubes, rods, etc. and screw manufacturing. And the rolling process, there are two types of rolling process. One is soft rolling and another one is cold rolling. So we take the slab, billet or bloom, these type of ingots we are taking, and the slab will be changed to hot strips, picklings, oilings, cold strips, welded pipes, steel plates and steel plates in slabs. Billet we going for rolling parts, and cold rolled round bars, wires and wire products and seamless tubes. These are produced by billets. And blooms, we get tube rounds, seamless pipes, structure strips and rails. Rolling basics. Sheets are rolled in multiple stages. Okay, in many stages they are rolled single and 1 or 2 times, 3 times they will be rolling. And the temperature also very important. Sometimes they go for the recrustation temperature around 600-700 degrees, and the ingot is inserted, the slab or ingot is passed into 2 rollers, and we can get the desired shape. So the example is screw manufacturing. So stationary die is there, and both dies will be rolling, and the threads are available in the dies. The 2 dies will be rolling. In the middle part you get the screw. So this is the rolling die, and also this is meant by reciprocating flat threaded rolling dies. So on be passing forward and reverse, you will get the reciprocating float thread rolling dies. And we go for the forging process. That is, metal is beaten with a heavy hammer to give the required shape. So you are giving heavy load. Load means that is ton of loads, and due to the ton of loads, the material will deform and it goes to the shape. And also the hot forging and open die. And also 2 dies are kept, and there is the pressing work is going on. When you press to work here, when you press, you will get the shape. Will get the shape of the design. Okay, so this is very important. And stage is in open die forgings. Forge hard billets to maximum diameter, that is fuller to mark step locations, and also forge right side diameters, and reverse part forge left side, and also finish dimension accuracy, dimension control. Right stage in open die, forge hard billet to maximum diameter, so that is giving the 2 dies, and also it comes to the diameter, and fuller to mark step location. These step locations are there, and also forge side forgings, and these are very important. Right, and stage is in closed die forgings, that is die, and both dies are there, and the blank you are pressing, and you are getting this type of shapes, and you are getting other shapes. One blank and edging, blocking, finishing and trimming. So this type you will get. So first blank bar and edging you are getting, and blockings, and you go for the finishing, and you are getting the products. And another one is meant by the quality of forged parts. Surface finish, dimensional control better than castings. Okay, the quality of forged parts is very important. So the surface will be finished. The surface finish will be very high, and they will get the dimensional accuracy and better than castings. The stronger, tougher than cast machine parts of same materials, and the plastic deformation is elongated, recrustation and growth of new fine crystals. This is the original core structures. When it is forged, so the crystallines, fine crystallines forms, and the crystalline growth happens, and that form the plastic deformations. And extrusions, so this is metal force squeezed out through a hole die, so that is known as the extrusions. So that is the metal is passed into a hole and you will get the desired shape. Typical use ductile metals, that is copper, steel, aluminum, magnesium, plastics, rubber. Common products: A-frame of white boards, door windows, all this can be used here. And this is the schematic view of the extrusion process, and there is one chamber is there, another chamber is here, hydraulic piston is there, stock is here, and you will have both the dies. So both dies are there, the hole is here. Okay, when you press into the stock, that you will get the extruded parts here, and this will be in this type of shape, whether it is plastics or metals. Okay, so direction of extrusions. Okay, direction of extrusion is very important, and the die feeder backbone, and this you will get the dimensions. So this is the schematic view of the dimensions. And drawing similar to extrusion, except pulling force is applied. Okay, there is a stock bar, there is one die is there, the die is there. The stock bar, you are pulling the force, commonly used to make wires from round bars. So wire from round bars you are making here. So these wires they are used to make round bars. Okay, and when we pass the stock bar into it, and it is the die, inside the die you will get the shape of wire. So due to the force of the opposite that pulls and make the common wires. So these are very, very important. Right, this go for the production of impellers. So these impellers are very, very used. So okay, the impeller shapes you are getting by this process. Okay, drawing process, and sheet metal process. That is raw material sheet of metal. So that is the raw material sheet metal process. That is rectangular, large in shapes. Okay, the raw material we are getting this raw material to the product, and the sheet of material is formed. So the sheet of materials will be in rectangular shape, and you will get the large sizes. Raw material process: rolling, anisotropic properties. Okay, the process: shearing, punching, bending, deep drawing. These are the processes of that sheet metals. So these processes are very, very very important for sheet metal processes. Next, shearing. A large scissors actions cutting the sheet along a straight line, main used to cut large sheets to small size for making parts. So that sheet metals are kept in the machines, and they are cut into parts. When you cut this, the parts will be very small. They will become very small, and also you can get a bit of small pieces into it. So that is going to be shearing. So along a straight line you are cutting, and with accuracy. That the sheet metal also should be accuracy. Next, typical bending operations and shapes. So that is some of the channel forming. So you will have, this is one type of bending like bending like. So this type of bending is known as channel forming. In upward drive will be, downward drive will be there, and it will be pressed. So it will go in some angle. That is called channel forming. And joggle is, this is one type of bending process. Upper one die is there, bottom one die is there. That is up and bend down, So this you will get some type of bend is there. That is known as a joggle process. And this is known as hemming. Hemming means you are bending the sheet metal. So taking the sheet metal, the corners are bent. So that will be safeguard for the persons to handle the sheet metal. That is known as hemming process. That is flattening. Stud tray lock scam. So that lock scam means that you are connecting the sheet metals. So one sheet metal you are bending to S type or L type, and they are connecting this. This is known as stud tray lock seam. And offset forming. This is offset forming. This is type of known as offset forming. The direction you are changing to one direction, like V, like that you are changing. This is known as offset forming. This is straight flange and stretch flange, and string flange, joggled flange, and also reverse flange. These are the shapes of sheet metals. And next, sheet metal bending. What is the sequence which we do the bending process? So first sheet metal bending process. The sequence is bending. So this is the type of sheet metals, and we have bent into the many sizes, that B1, B2, B3, B4, B5, B5 like that. And this one is is the bending process. This is also a bending, and you will get the two pathways of bending. So another one is known as upward bending is there, and these two parts of bending is there, and that is connected with one and one. So avoid part tool, part machine interferences. So we are avoiding that. And bending machines, okay, bending mechanics, bending planning. What is the length of blank we must use? That is the bending allowances, and this is the under extension action of the bending. So sheet thickness is there, the bend length is there, the bend is, this is the bend reinforced, and here it comes the shape. So this is meant by the neutral actions. This section is in compressions. Okay, this is neutral axis. Next, deep drawing. Tools similar to punching operation, mechanics similar to bending operations. Okay, this is known as the similar to punching operations. Okay, here we are keeping this blank is there, the punching is there, then we are pressing and getting this. This is the blank border is there, and it is punched, and you get the punch is inside, and the part has been changed. So this you will get this shape of this. Okay, this is known as, this shape is very important like that. This is cooking pots, containers, etc. Examples of deep drawings. Okay, so this is meant by we are taking one tray, and we are keeping on another tray to these levels, and that is very important for us. And this is the round shaped. Okay, round shaped, and this is one of the shapes we are getting in through this. So this is very important for us, and this shape is formed like this common cooking pots or containers like this we have formed here. So this is one of the important process for us. So it gives important to the materials, in what materials we are using this, and what are the applications we are using. The sheet metals are mainly used in many of the applications. Okay, for most of the covering bodies, that sheet metals are used. These are very important. Okay, this will be very important for us. So this contains some of the holes here, and some of the bending, 4 bends are there. These bends are used for the application purposes. This is meant by a tray. So this is one of the deep drawing process. And thermite welding is a mixture of aluminum powder and metal oxide, which when ignited results in a non-explosive exothermic reactions. The heat source generator melts and reduces the metal oxide to metallic form at high temperature. This molten metal is used for joining metal parts by pouring it between them, result in casted joints. Okay, so this is the application of this is the construction of that thermite weldings. So the mixture of aluminum powder and metals which ignite results in non-exothermic reactions. So in that reactions, heat is generated with high temperatures, and that forms that the space for this, and that you will get this shape. Okay, mold for thermite welding, pouring that gate path of molten. The lines the charge of magnetic ions and scale. A magnetic stone is here. Line crucible magnetic system is just tapping that, and we are pouring the gate into it, and that it will give the shape of it. Okay, this molten metal is used for joining metals by pouring between the resulting in cast welded joints. Okay, so for join the cast welders, we are using this. And laser beam produced by a laser welding. So laser beam produced by a carbon dioxide laser, white laser is known as. So this is concerned the heat flow. So low distortion laser can be saved. So the laser is very high accuracy by use passing the laser yttrium gas oxide, and you are passing to it, and you will get the shapes. So typical laser welding applications: catheters or other medical devices, small parts, components, fine wires, jewelry, small sensors, thin sheet metals down to 0.001 thickness. So that very thick, very minute thickness parts that you can pass. That is meant by light amplification, stimulated emission of radiations. The radiation is passed into the materials. Okay, the materials, and you will get into that a high accuracy of accuracy on it. So the product's accuracy will be very high. So for a thin and thick products, any type of products, the laser welding is very important. So this is meant by ultrasonic welding. Ultrasonic, a metallic tip vibrating and ultrasonic is made to join a thin piece to a thicker piece, supported on anvil. Frequency used is 20 Hz to 60 kilohertz. Ultrasonic welding equipment consists of mainly two parts. One is power source, another one is made by the transducers. So this is metallic tip vibrating at ultrasonic frequencies. So this is meant by the ultrasonic process. And here you see the pneumatic cylinder resistors, piston with piston rod is arranged here. Resettling spring is here. More springs are resettled here, and attenuator is here, and forced transducer is here. This is meant by the converter, and here you see the booster, and sonot rod and workpiece and anvil. Anvil with base plate, and this is generator. Carriage with clamp facilities and column with flat guide way, feed displacement scanner base is there, and holder and guide for feed units, setting for basic distance between sonotode and anvils. So tip vibrating ultrasonic made to join thin piece, thicker piece supporting anvil frequency. Due to the frequency in the anvil, so this piece, this workpiece is as joined ultrasonic welding. The ultrasonic, this is the base plate is here, and the control generators. And due to the forces and due to the ultrasonic vibrations within one or two parts, so there is a chance to get this, due to these vibrations, the metal will be joined. Okay, that is what we call the explosive forming. First used to form metals in 1900, a sheet metal blank is clamped over a die, and the entire assembly is lowered into a tank filled with water. The air in the cavity is evacuated, and an explosive detonated at a certain height above. Right. This is meant by a form of this setup. And here it is tank, and here is this vacuum line, and it is a die. Hold down ring and work material, workpiece is here in the ground level. And also here this is meant by stand off, and here is known as the cartridge and forming die, and the work tube is kept this side. Okay, so this is immersed inside the water, and there is a vacuum line due to the vacuum also sent here, and the tank is there, and go for this, and the explosives allowed to expand. Yes, they explode inside this, and also so when it is passed into it and this is exploded, when it explode, you will get the shape of one round. So the entire assembly is loaded in tank filled with water. The air is cavity is evacuated and exploded at certain height above. So this is that when you pass this, that you will get the shape of this explosive. So you will get this. Next, rubber forming. One of the dies in the set is made of polyurethane membrane, which is a type of flexible material. Okay, polyurethane resistance to abrasion, cutting or tearing by the metal, and has a long fatigue life. Okay, one of the dies set is made of polyurethane membrane, which is a type of flexible materials. So this is meant by the rubber that is you are going for the shape. Okay, the die sheet of shapes, and your flexible materials. So resist abrasion, cutting, tearing by the metal, and has a long fatigue life. Okay, so this is a type of polyurethane material or flexible materials. So that is by pressing this rubber, you will get the shape. And spinning, that is conventional spinning process, where a circular piece of sheet metal is placed and held against a mandrel and rotated with a rigid tool, deforms and shapes the material over the mandrel. So maybe performed at room temperature or at a higher temperature for thick materials. So here you are seeing the mandrel is there, and the blank we are keeping, the tool we are pressing here. So due to the mandrel, so this will be rotating, and the blank we are keeping and the tool you are pressing. So you will get many shapes, 1, 2, 3, 4, 5, 6. These shapes you will be getting. You will be getting the shapes, different type of shapes. These shapes are very important. Okay, you can get the shape very accurately to the concerned shapes. So this is round shape or vessel shapes or dome shapes. Any shapes we can get using this spinning process. Okay, there is one die is there. The die will be kept it here. So this die it can be used to process many shapes. So the mandrel shapes can be changed according to the work requirements. So if it is round, you can create round, and conic or any shape, conic shell or any shape you can get by using this spinning process. Right, powder metallurgy. Basic steps in powder productions, blending or mixing, compaction, sintering and finishing process. Very very important. That is powder maturity means making the powders to the very minute or micro or nano level of powders we are making. These powders are very very important. This the production is made first of all. First the production of powder is very very important, and another one is it is mixed with other elements for bonding, and also due to for some characterizations we are mixing other elements, and the compaction is very important, sintering, and finally the finishing process. This is when by powder production. The atomization, the most common. Other chemical reducers of oxides, electrolyte deposition, different shapes produced will affect compactions process significantly. Right. See, this is one of the main processes there. This is this dish, and here the waters, and this is melt. So the molten metal is there. This is meant by like a vessel pot. Inside you are keeping that is cupola furnace, that cupola this vessel is there, and inside you are keeping the molten metal is there. Here small a hole is there. A small type of hole or jet of hole is here inside. That is because the whole nozzle. Okay. And the molten metal will be pouring from up to the down lower level. The molten metal will be pouring, and water or gas. So you are passing the water or gas in the opposite directions. So mostly we pass the water due to the cold water or due to the flow properties of this water. We are passing this water into the molten metals. Okay, when water is passed into the molten metal, the powder will fall down. Powder, you get the powders. Okay, so this powders you can categorize, you can separate it, and you can get some many types of powders. That is micro, nano of powders you get. Okay. So this is when by one-dimensional acicular chemical depositions, irregular rod-like chemical depositions, mechanical components, two-dimensional dendrite electrolyte components is there, and flat mechanical commutations, and three-dimensional round atomization chemical depositions, angular mechanical disintegration components, porous radial oxides, spherical atomizations, and carbon for a liquid, irregular atomizations in chemical shapes. These are some of the main of the shapes atomizations. So the production of metal process is very very important for the manufacture of cutting tools or hard materials, and all these things are very very important in the powder productions. The metal products are used for making many products. Blending or mixing can use master alloys, mostly elemental powders that are used to build up the alloys. Master alloys are with the normal alloys ingredients. So master alloys are using elements or pre-alloyed metal powders are first mixed with lubricants or other alloys additions to produce a homogeneous mixture of ingredients. So the elements of pre-alloyed metal powders are first mixed with lubricants or other alloys addition to produce a homogeneous mixture of ingredients. Okay, the initial mixing may be done by the metal products or the PM parts of the manufacturer. When the parts are blended, also media and glass media and glass. Can use master alloys. Mostly compounds or element powders that are used to build up the alloys. Master alloys are with the normal alloys ingredients. Element or pre-alloyed metal powders are fixed with lubricants or other alloys addition to produce a homogeneous mixture of ingredients. The homogeneous mixture of ingredients will happen here. You are mixing this with more ingredients, you will get the consistent products. The initial mixing may be done by either the metal powder producer or the product manufacturers, and when the particles are blended, decide to produce a homogeneous blends, or mixing will work harden the particles and produce variability in the same centering. Usually gravity filled cavity at room temperature pressed at 60 to 100 kilo, that is produces a green compact. Size and shape of finished parts not as strong as finished part handling. Friction between parts is a major factor. Okay. Top punch is there, filler is compacted parts. You'll get this, and you'll have the both the dies will be there. That is flowing will be going on. Isostatic pressings remove for all charging full molded. So here is the mold of parts. Remove for full molded. Pressurized part eject is here. Here you are keeping this isostatic pressing ones. Because of friction between particles, apply pressure uniformly for all directions. You are applying the pressure for wet bag left, dry bag right. So you are getting the this is the isostatic process. Sintering. Parts are heated to 80% of melting temperature. Transform compacted mechanical bonding to much stronger metal bonds. Many parts are done at this stage. Some will require additional processing. Parts are heated to 80% of melting temperature. Transfer compact mechanical bonds to much stronger mechanical bonds. Many parts are done at this stage. Some require additional processing. So sintering means that is the making bond of the materials. So the metal powders are taken and it is 80% that is heated and that is melted to the temperature and that is pressed and compacted. So and by that the strength of the bonding will be high, stronger, and the metal bonds will be happen. Many parts are done at this stage. Some will require additional processing. Okay. So mostly in the cutting tool manufacturing process, they are keeping the titanium, tungsten, carbon, aluminum metals or anything. So in the powder they are putting tungsten powder, they are putting into it and they are heating it. And by pressing, they will get the hardened materials and it will go for the bond. The bond will be very high. Okay. And the biggest hardness value will be 2500, 2000, 3000 like that, 2008, 700 like that. So due to that, cutting tool materials that are used to cut the products in the machineries, and that is very useful in sintering. So most of the hard materials are made by this sintering process. Most of the manufacturing by using some manufacturing convention, non-conventional, it is very hard for the hard material to bring it to the shape. But in the sintering process, we can bring all the material to the shape, in the concerned shape. When it becomes in the concerned shape, so this process very easy one. You are taking the metal powders and melting that, and you are making the product to the required directions. Design of die for the process of that is manufacturing. The thin walls and projection create fragile tools. Holes in percentage can be round, square, D-shaped, cage splits or any straight through shape. Draft is generally not required. Generous radius fillets are designed to extend tool life. Chamfers are the radius are necessary on the parts to edge. Flat stress chamfers eliminate further edges and tools. So this die designs, how we are going to make the side die designs. So this is very important. The die designs that will the die should be in the shape of round, not the corner. Okay, all the chamfering, so the shape should be curved, not in the straight way. Right. So sintering continuation. Final part properties drastically affected. Fully sintered is not always the goal. So the dimensions of parts are affected. So this will be the time will be here, the density will be here. The dimensions change in the temperature 1120, 1230, 1315 Celsius, the Fahrenheit, 1315 Celsius. These are the Celsius temperature. It's a green compact net formed pore size reduction fully sintered. So these are the process, right? Okay. So advantages are virtually unlimited choice of alloys, composites and associated properties. Refractory materials are by this process, the sintering process. Control porosity for self-lubrication users can be very economical large run sizes. Long-term reliability through close control dimensions, physical waste properties, wide latitude of shapes, very good material utilizations. Limiting size curve due to large forces machines need to control the element conversion to concern will not typically produce parts as strong as wrought iron, can repress into overcome that. Cost of die that are forging is more specifically less well known process. So this is some of the disadvantage of That is the process. Financial comparison. Die design must withstand 100 close cycles, requires physical resistance, can be authorized 1500 parts per hour, not uncommon for average sizes. 6000 parts per hour achieved for small, low complexity parts in a rolling press. Typical size parts for automation is 1 inch cube. Large parts may require special machines, large surface area, same pressed, equal large force involved. So manufacturing of plastics. Raw materials in the form is thermoplastics, pellets, granules or powder placed in the hopper and fed into extruded barrel. The barrel is a screw that blend the pellets and conveys them down the barrel. Heaters around the extruded barrel heated the pellets and liquefies them. Screws has 3 sections: feed sections, melt or transition section, and pumping sections. So the raw material is in the form of thermoplastics, pellets, granule or powders. So some plastics will be pellets, small parts and round parts, or some of the powders. So that is placed in the hopper. That is fed into the extruded barrel. So that's barrel. The barrel is a screw that blends the pellets, conveys them down the barrel. Heaters around the extruded barrels heats the pellets and liquefies them. So lastly, while heating the raw materials of plastics, that will melt and pass to it, and you will get the shape, that is feed section, melt or transition, and pumpings. Complex shapes with constant cross sections. So you can make this complex shapes with constant cross sections. Solid rods, channels, tubings, pipe, window frames, architectural components can be extruded due to continuous supplies and flow. Plastics coated electrical wires, cables, and strips are also extruded. So these are some of the applications of this. Some of the parts what you can be extruded by using the plastic process. That solid rods are there, and the channels, grain rod channels, the tubings, pipings, window frames, architecture. So most of the components that can be extruded or that can be made by the plastics. Plastic coated electrical wire, cable, and strips are also extruded. The plastic coated electrical wires are there, and cables and strips are also used, also extruded. Pellets, extruded pellets produce products in a small diameter rod which is chopped into small pellets. Sheet and film extrusion. Extrusion process allowed to on water and on the rollers. Right. Okay. Sure. So now this is the construction of typically extruded for plastics, elastometers, and composite materials. So this is the construction of the extruder, and gear reducing one motor is fixed to the gear reducers. Another you will have that one hopper is there. In the middle part there is a screw, right? Okay, that screw will be going, and the throat is there, and the barrel line is there, and the barrel is there. Barrel heater, cooler, thermocouples, and filter screen, that is breaker plate, melt thermocouples, adapter die. And the two types of zones are there. One is meant by the melting zone, and this melt pumping zone. Okay, so in the hopper, that is the pellets or the raw material is poured into the hopper. So due to the poured into the hopper, there the freeze zone, that is melting zone, is there. So that metal melts. Okay, and in the first zone, that is throat cooling channel is there, that will be melting. So melting. In the initial, there is some cooling process is there, and that in the secondary some heating process is there due to the melting gas, and this melting pumping zones, and that will be breaker pellet is there, and the adaptive section is there, and in the last there is a jet-like die is there, and also you get the shape of the extruder, that plastic sections, and both dies are there. So you are passing the extruder, that is melted. First of all, you will put the barrels of the metals, and that will be heated again slightly the semi-cooled, and it will passed into the die. Both the die, the small area is there. Due to that type of extrusions happen. Injection molding process. So this is meant by injection molding process. The powder belt does get pistons. There is the same construction, cylinder, injection mold, and spreaders, heating zone is there, and nozzle is there, molder process. Then we are ejectors is there, ejectors to ejectors are kept here. The vent is there, and due to that press clamping is there. Due to pressing, so you will get the shape. So that is the injection molding. Injection chamber is there, and sprue. The sprue is there, the path of the metal flow, and the molded part is there. First of all, the powder pellets are kept here, and there is the one type of piston is here, and when you pour the metal part here, you will get the shape. So this is also a type of injection mold process. And this is similar to extrusion barrel is heated. Pellets are balanced fed into heated size cylinder. Melt is forced into a split die chamber. Molten plastic pushed into the molding cavity. Pressure ranges from 70 megapascal to 200 megapascals. Typical products: cups, containers, housing, tool handlers, knobs, electrical and communication components, toys can be produced. So, injection molding have several components such as runners, cores, cavities and cooling channel, inserts, knockout pins and ejectors. So three basics type of molds: cold runner plates molds, cold runner plates 3 molds, hot runner molds. So these are some of the components that are made by the injection molding process. So this molding process, there is this plastic stout round shapes which is got the extension projection here, and this type of complicated design of products that can be produced by the injection molding. So this type of plastics can be used in the machinery components, and here also one type of round component is made of injection molding process, and there is some projections there, some holes are there. So this type of a flattened part is made with holes. This is also one type of designs that can be used for the switchboards or the elements can be used here. So most of the switches and the electrical wires and everything can be made by the injection molding process. And here the plastic chip which is connected with the metal product is here. This metal is there. This metal that is inbuilt into it, and here also some of the products are here. And process capabilities there is high production rates, good dimensional controls. The rate of production of this is very high. The production rate will be high, good dimensional control, and cycle range of 5 to 60 seconds. So the range of this production is very low, that is 55 to 60. Mold materials, tools, steels, beryllium, copper, aluminum are used. Mold life 2 million cycles, steel molds and 10,000 AL molds. Machines, horizontal or vertical machines, clamping, hydraulic or electric. So next we go for the blow molding, modified extrusion and injection molding process. A tube extruded and clamped to mold with cavity larger than tube diameter, finally blown out to fill the cavity. That is pressure is 350 kilopascal to 700 kilopascals. And the injection molding process is by the multi-layer process. That is a multi-layer blown process. That's the injection molding will be the multi-layer blown process will be there. And modified extrusion injection molding process, there will be the extrusion process also will be there, that the injection molding also. The blow means the high of energy or high of that kilopascals of load is pressed into it. Tube extruded that clamp to mold the cavity with the larger than tube diameter, fine blown out to fill the cavity. So the pressure will be 350 kilopascal and 750. Other blow molding process, injection blow molding, multi-layer blow molding. Okay. Okay, rotational molding. Thermoplastic or thermosets can be formed into larger parts by rotational molding. A thin wall metal mold is made of 2 pieces, rotational about 2 perpendicular axes. Pre-measured quantity of powdered plastics metal is rotated about 2 axes. Typical parts produce trash cans, boat hulls, buckets, housing, toys, carries, cases and footballs. So this type of process is known as rotational molding process. So rotational molding process, you will get the symmetry shapes we are getting, rotating about 2 perpendicular axes due to rotation of 2 perpendicular axes. So due to that we are getting the desired shapes. So in that shape, the shape will be in a cylindrical shape or a semi-cylindrical shape or in a round shape. So typical parts produced are trash cans, boats, hulls, buckets, housing, toys, carrying cases and footballs. The casting, right? Conventional casting of thermoplastics. Okay, this is meant by liquid plastics, and there is a mold mixture of monomer, catalyzed and various energies are heated and poured into the mold. The desired part is formed after polymerization takes place. A centrifugal force used to stake the materials onto the mold. Reinforced plastic with short fibers are used to form this. And you go for the mold, and the liquid plastics are poured in the moldings. So due to this, that you can get the various type of plastics. Okay, monomer, catalyst and various are heated and poured into the mold. The desired part is formed after polymerization takes place. So in centrifugal casting, centrifugal force used to stack the material onto the mold. Reinforced plastic with short fiber used. Right, cold forming. Process such as cold forming, de-drying, extrusion, closes, die forging, coining and rubber forming can be used for thermoplastics at room temperatures. So rolling, so the cold forming is a type of rolling. Due to rolling, and at room temperature we are doing this cooling process: rolling, deep drawing, extrusion, closed die forging, coining and rubber formings. So rolling means rolling the component and getting into the desired shape. The shape may be in the as diameter or long wire. So deep drawing means making some of the components, taking the components and passing into the extrusions and making some wire formations. The long size wire by two dies. Coining, making coin sizes with the round diameter and with thickness 1 mm, 2 mm, and the rubber forming, and you can form the rubber by using the thermoplastic at room temperatures. So these are some of the processes. Typical material used is polypropylene, polycarbonate, ABS and rigid PVC. So these are the materials. Concentrations, that is sufficiently ductile materials at room temperature, non-recurrent material deformation, that is a solid forming process. The advantage is there is temperature to form temperature to 10 to 20 degrees they are used. Okay, temperature to 10 to 20 degrees are made, which is below melting point. Okay, and this cold points, what are the advantages? That is, it is a easy process. This is a easy process, and this process can be made for all the materials, for the plastic materials. The process is very fast, 50 to 60 seconds, and you can manufacturing the coins and die forge material very easily. So these are the process, and the quality of the materials will be high. So the temperature in the solid bed 10 to 20 degrees are maintained, which is below point. Okay, calibering and examples of reinforced plastics. Okay, so the calibering sheet metal product by this process subsequently is thermoforming. In thermoforming, more rollers are used, and this rollers the products are passed into it, and also you get the desired shape. Okay, reinforced plastic components of a Honda motorcycle, washer in front and rear forks or rear sims, wheel and brake discs are used by the calibering this process. So this is one of the main process in this. Okay, and the rollers are there, and due to the rollers, that the schematic process is in the thermoforming. We are passed into the rollers, and you get the desired shape of the products. Okay, so this is one of the main importance product in it. On revision of this. So first we have seen the rolling process. The rolling process, you're passing the materials to two rollers and getting the desired shape. In the hot rolling and cold rolling process, that is basic rolling process, we are using the screws are manufactured by this process. And in the forging, high impact load is passed in it, and you get the desired shape. This is by the forging process. The die process, open die and closed die process, you can manufacture, and the die forging is by die forging heavy load is passed into it, and the for process that even the band edging, blocking, finishing and trimming process there, and quality of the forged process will be high. And the extrusion process, the product is passed into the roller and you will get the desired shape. The extrusion process that you are with both the die you are passing it, and you are manufacturing many products like impellers, etc. And the shearing process is making the sheet metal to the desired shapes, and you will have the sheet metal many operations, channel forming, jogging, hamming, two-stage offset forming, sheet metal bending process, and the bending mechanisms, and thermit welding. So what are the welding process, how the welding process is done? So joining of two materials by different, that is laser welding or thermit welding, ultrasonic welding, and also the forming of rubber process. This is one of the important process, making the shape of the rubber, and the spinning process, making the shape of the product in the desired shape. And the powder metallurgy, you can see the automations. In the automations in the small melting zones, you are pouring the molten metal and getting the design shapes, and blending machines, and the pressing process and complex and eccentric process, and die manufacturing, die compacting. All these are very important. And the manufacture of plastics will go for the extrusion process and injection molding process. So injection molding is very important in plastic manufacturing. The process capabilities we have seen, and the rotation molding, the axis that is rotated and you get the products, and the cold forming, hot forming process, and the plastic manufacturing. So finally we go for the calibering and the process. These are made for the for manufacturing the automobile products by different shapes. So that is going to be the calibering. So in the reinforced plastics, this calibering is very important. So this is these are the some of the main points of manufacturing technology. So I thank everyone, management, for giving this good opportunity. Thank you.